Hello everybody. In the previous video you should have kind of been introduced to the idea of variance and standard deviation and how to find those things by hand. So just to recap, remember that you're using variance to find standard deviation, and the way you find variance, it's kind of like taking the average of the differences, or excuse me, the average of the square differences between the mean and each value in that data set. So you take each value in that data set, find the difference between the mean, square that value, sum all those values together, and then divide by however many values you have, and that's how you get variance. And then using variance, you can find standard deviation by doing the square root of those. Now, what those tell us for a data set, it tells us basically how much this data, I guess for any data set, it tells you how much it's spread out. So standard deviation, that's the one where you take the square root of variance. It tells you how spread out a group of numbers is from the mean, whereas variance, it kind of tells you, like on average, how much each point differs from the mean. Okay, it's like the average of all the data points, whereas the standard deviation, it tells you how spread out everything is. And standard deviation might make a little bit more sense in the last example we're going to work through today, but you should have seen in the previous video how to find these things by hand. I'm going to show you how to use Desmos. You're allowed to use Desmos on state testing, which we didn't have this year, but you are allowed to use Desmos, so I'm going to go ahead and show you how to do that for certain things. So we have this data set here, and it displays the number of U.S. hurricane strikes by decade since 1851 to 2000. We want to find the mean and standard deviation of this data set. And what that means is we want to find the mean and standard deviation of the strikes. Okay? So what you can do is you can enter this data into Desmos, and then we can use Desmos and a bunch of features to find certain statistical information, and we'll talk about that. Now I've already created the table here, and I've let my x-axis be the decades. Usually you want your x-axis to be time, so I stuck to that general idea. And then the y values stand for the number of strikes each decade. So in the first decade, that would have been in 1850 through 1860, or I guess 1851 through 1860. There were 19 hurricanes, so on and so forth. Okay, now if you're wondering how to get the table, remember, just go to this plus button, click table, and then it'll give you an x and a y value here. So I've entered my table. The question asked us to find the mean and the standard deviation. Okay, now I'm going to go back in a little bit and show you all these functions, but we'll just find those immediately. So to find the mean, that one's easy enough. You just type in mean. Excuse me, I'm typing on the wrong keyboard here. You just type in the mean, and then, well, we're finding the mean of the data set. We're really finding the mean of these hurricane strikes. And this is really the data we're looking at. We're not too concerned about the mean of the decades. We're looking at the mean of the data strikes. So we take mean, and then whatever column we want to look at, in this case it would be Y1. We put that in parentheses, Y1. And if you just type in Y1, it'll automatically subscript that, and it gives us a mean of 17.6. So there's an average of 17.6 hurricanes each decade from 1850 to 2000. That's what that's telling us. Okay, to find standard deviation, it's STDEV, and then a similar thing. We want to look at the standard deviation of Y1. Okay, so the standard deviation is 3.6. So that tells us how spread out a group of numbers is from the mean. It means that everything is about 3.6 standard deviations from the mean. What the heck does that mean? We'll talk about that in a little bit. But what we want to do here is, well, let's go back and write this down. So go back to my things. Okay. The mean we found in Desmos. Remember, that's just the average. You add all the things together and divide by however many things we have. Well, we found the mean was 17.6. There's about 17.6 hurricanes each decade. The standard deviation was, and I already forgot, what was it? I think it was 3.64. Yeah, 3.64. Okay, now all the things we've talked about so far, quartiles and mean and median and things like that, we can find all of these. There's functions for all of these using Desmos. And if you want to write these down, that might not be a bad idea. You can just use these functions. And they're all going to work the exact same way. The only one I'm going to go over is those quartiles here. So to find the quartiles, you want to type in quartile, and then we're reading from the Y2 column again. And then you have to specify which quartile. So I want the first quartile value. Oh, maybe. Oh, whoops, I typed in y2. We want y1. And then I want quartile 1, and it'll give me the value for quartile 1. That's basically the median of the left side of the table values. If I want, well, you can also find the median here, but I'm going to show you something. Let's do median. And then we're going to find the median of the data in y1. And I spelled median wrong, that's why. Okay, 18. Now we also know that the median and quartile 2's value should be the same. So if I do quartile, I'm reading from y1, I want the second quartile value, it's 18. Notice those are the same thing. So you can use Desmos to find all of these statistical values we've had. It's kind of a good way to check your work. Okay, so you can maybe go through and practice doing each of these on your own. See if you get the right answer. You can always double check that by hand. Now, problem 3, we kind of are going to explain how to use standard deviation to describe data. So we want to use the data from problem 2, and we want to know how many standard deviations from the mean do all the values fall. Now, I kind of misspoke earlier. I said our standard deviation was 3.6, which means everything lies within 3.6 standard deviations. While that's true, that's not what 3.6 necessarily tells us. That just tells us about how spread out a group of numbers is from the mean. Okay, it's like saying that on average, it's kind of a confusing concept. It's like saying that certain things are going to fall within so many standard deviations. And I'm kind of making this a little bit more confusing. It'll help once we work this example out. You'll kind of see what a standard deviation is. And it's really used a lot, and we're going to cover tomorrow when you're talking about distributions and things like that. Okay, but we want to know, well, from the data, how many standard deviations from the mean do all the values fall? Well, we know our mean, our x bar, our mean value, our mean was 17.6. We want to know how many standard deviations from the mean do all the values fall. Well, one standard deviation we found, remember it's denoted by that Greek symbol sigma, one standard deviation was 3.64. How many standard deviations do all the values fall? Okay, well, that means we have to look at our most extreme values in this data set and see how many standard deviations they are away from the mean. So let's find our most extreme values. And it looks like the most extreme values we have, the most hurricanes we ever got, was about 24 hurricanes in a single decade. And the fewest hurricanes we got was 12. So we want to see how many standard deviations our furthest values are. How many standard deviations from the mean do all the values fall? Well, since those are our extremes, everything has to fall within those extremes. So we want to see, well, if this is our mean, our x bar, kind of in the middle, is 17.6, how many standard deviations away is everything? Okay, and I'm going to actually do standard deviation in blue here. Well, if this is about 3.64, well, one standard deviation to the right, that's like adding one standard deviation. Well, 17.6 plus 3.64 gives me 21.24. Is that going to include our extreme value of 24? And I guess I should write most extreme values we have. Are 24 and 12. Okay, well, no, 24. Let's try another standard deviation. Okay, well, we're plus 2 standard deviations to the right of that mean, and that puts us at, well, 21.24 plus 3.64 gives us 24.88, which, well, we know that our most extreme value to the right, our highest extreme value, 24, is going to be within that. Okay, so it's within 2 standard deviations to the right. What about to the left? Okay, well, if we go minus 1 standard deviation to the left, we're going to be at, well, 17.6 minus 3.64 gives us 13.96. We're still not quite there. Let's go one more standard deviation. So if we do 17.6 minus 2 standard deviations, we're going to be at 10.32, meaning, well, 12 is going to lie within 2 standard deviations to the left. So one problem that students do is they say, well, I had to make 4 total standard deviations from the mean. It should be 4. But really, how many standard deviations from the mean do all the values fall? What that's saying is to the right and left. So if you look here, well, this technically is a distance of 1 standard deviation to the right and 1 standard deviation to the left. So this is still 1 standard deviation. Okay, so really, everything falls within how many standard deviations, and the answer is 2 standard deviations. And I don't like this red highlighter. I'm changing that. That's going to be green. All right, so everything falls within 2 standard deviations of the mean. Okay, hopefully that kind of clears things up a little bit more. I misspoke a little bit earlier. So just in summary, make sure you know how to find these standard deviations by hand and also by Desmos. That's going to save you some time. Standard deviation, the difference between that and variance, they're very similar. Standard deviation just tells you how spread out a group of numbers are, and maybe it makes more sense in this application when we're talking about how far away things are from the mean. That's kind of how you use it to explain stuff. Whereas variance just measures the average, like usually the average degree to which every point differs from the mean, from each point from the mean. Okay, so that's all we're going to cover today. We're going to use the standard deviation a lot more when we talk about normal distributions and things of that nature. So have a good day, everybody, and as always, stay safe out there.